What I'm going to talk about today is something that is less technical and more about how we develop technology. And this is how the security industry sees open source, its benefits and its caveats, and what happens when security sensitive components come from open source, or when open source comes into security sensitive environment. I work for Cossack Labs. We do build security tools and solutions. Some of that we put in open source. Some of our open source relies on other people's open source, and we contribute quite significantly to open source security projects. So we've been in all three typical positions of people involved with security and open source. We develop, we use, and we commit. Let's take, for the sake of this call, of this talk, 5 simple views of 5 persons about the way what is good and what is bad about open source. Ivan, the developer, who doesn't want to write a lot of code. Open source is magic. I can deliver faster. His boss, she's Anne today. She's happy. She meets deadlines faster. Then we've got a corporate strategist who understands that open sourcing some internal technology means punching competitors in the face, eating their revenue and earning something. Then we have a nice fella who thinks that keeping things open source, low quality, unaudited is a very good opportunity to exploit that. And then we have a retired developer who back in the day used to audit each line of code that goes into production, and who knows that, well, if you haven't verified it, it's your fault. Back from the day when Joe was a software developer, up until today, the amount of not your code grew slowly from 30% to 50 to 60, and in worst cases to 90. So basically, sometimes right now, software projects are, you run other people's code, and you just run code some wiring for it. That's it. What happens when a company becomes security conscious, or reliability conscious, or risk conscious, and starts asking questions like, where do we go from here? It's a lot of risks. The situation is irreversible, basically. Right now, we're in the situation where we need to multiply the development teams, we need to move time estimates, and if we are lucky, we can substitute all of our open source with properly written code, and there is no guarantee that it will be properly written. So, this irreversible situation is agreed by everybody. However, nobody looks quite well into what risks do we retain when we keep on running open source code the way we do. There are 3 layers of risk out of perspective of security engineers' eyes. 10 years ago, when you would supply your tools to somebody, the probability of having a security engineer on the opposite side would be 1 to 1,000. For each CTO, for 1,000 of CTOs, you will have some chief security officer who will say no. The situation is changing, the market is changing, there are more risks, more flaws, and more CSOs. So what the CSO will see when you are trying to introduce new open source software into the stack? Immediate risks. Risks which are first contagious, and second, you never know when they blow up. And risks which are not about technology, they are just bad design. We'll go through all of that. When we will finish, we will try to spend some time talking about how to change the shape of the open source software we ship so that risk-averse, risk-sensitive people would be more comfortable running it. But let's start with the risks, they're more fun. Immediate risks. Ownership, you never know who actually owns what you run. Quality, it's obvious. False expectations and dependencies, we'll go through that. Ownership. The reliability engineer's nightmare is a boss hitting lonely developer who actually can't maintain stuff anymore, so somebody has to pick it up. The security engineer's nightmare about ownership is different. Somebody gives up a project, a popular one, someone else takes it over, spoils it with infectious code, and voila, the Node.js dependency used by a lot of Bitcoin automation is now populated with code that steals wallet keys. Quality. In boring enterprise software development, there is an idea of software development lifecycle. There are many things which should happen one by another for the software to be developed properly. When software engineer from a boring industrial environment or enterprise environments looks at the way open source software is developed, he sees this. And then he sees this because some original idea has been done wrong, and now we need to fork it into 5 different projects and figure it out from the very beginning. The vendor who does ship commercial software has all this fancy development life cycle, iterative development cycles, yada, 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 and he seems to be much more understandable to both security teams, reliability teams, and so on. However, when there's charged money, they are slower than open source community, and we do have to live with both. Then we've got false expectations. An experienced developer considers that since the source was open, there are many eyes who studied and tried to understand what's going on behind the bars. However, what happens in reality, most of these eyes don't have enough qualification for reliability issues, for scalability issues, and for security issues. Every time these eyes come and try to fix security and reliability issues are when these issues happen, actually, not before they happen. So the quality of source code review in the eyes of the security engineer in the open source is quite questionable. Moreover, in the security and cryptographic projects themselves, most of the time bugs get fixed when they become public and annoying. However, these false expectations play a very good assistance to the hackers. Because once our anonymous guy takes looks and sees that within 200 GitHub issues, nobody raised the security concern, he's like, okay, nobody looked at that. I'm going to be the first one, but I'm not going to report. I'm going to use that. I'm not going to spend too much time on dependency hell, because it's self-evident right now. We have a separate industry for scanning for vulnerable dependencies and unobvious things that will go bottoms up in 3 layers of dependencies you've accumulated in your project. Let's go to more interesting stuff. Stuff that's contagious and that hits you unpredictably. Design. There are many things which you will find a hard time designing if you're not a security professional. How many people in the audience know what these 3 abbreviations mean, or at least one of the 3? Well, you see the idea, but significant part of the open source projects have to implement some kind of access control. Yet, it is implemented by people who don't really know the science behind it. These abbreviations are discretionary access control, the old school crap we don't want anymore, role-based access control, the easy stuff that is easy to misuse, and attribute-based access control, which is hard to misuse but very hard to implement right. Then we've got another stuff, cryptography. Cryptographers have been crying for ages, please don't invent and implement cryptography. This is something that you will most definitely do wrong. And then we've got ACB penguins and all the copybook Bible vulnerabilities all over the place, again and again. Security engineers have been raising for a while that data validation, input sanitization isn't as straightforward as copy-pasting a few bits of code from Stack Overflow. Yet, somebody managed to print these car plates. Design isn't easy. Governance. Aside from just ownership, which is a tricky problem itself, The next problem is, once I am a security director of a large enterprise and I use your stuff, I want to know to whom I will talk and to whom I will try to press my budget or whatever for support to make sure that my priorities are met. To the maintainer, to the owner of the repository, to the head informal of the community, what if they change tomorrow or overnight? Is there a corporate structure behind that? Governance is still a problem, and as open source developers, we are making it actually worse. Because when we can show some kind of organizational merit behind our open community, instead we say everybody's free and everybody's equal. So the security engineer and security director, they just turn their backs and go to IBM to pay a few $1 million. That's basically just repeating my words. For a security personnel, to big extent and to smaller extent to site reliability teams, governance is all about when crap hits the fan, what do we do? Whom do we talk to? Once again, governance and the boss. If you're a sole developer and there is a boss somewhere that is going to end your unfortunate life, you're not going to be within the supply chain of a high-risk project. Quality. Things by which large enterprise software is measured is slowly getting adopted by modern tech giants. Mean time to recovery, mean time to detection, mean time to failure, mean time between failures are 4 metrics regardless of the process. It doesn't matter how you develop. It is the way to measure the quality of your product. Mean time between failures, completely unpredictable for a open source thing because nobody knows the prior failure. You just put your code out there. Mean time to failure. Nobody actually tracks user experience and you don't know the frequency of security, reliability, or whatever failures of your tools. Mean time to detection, even worse. Yeah, they wrote you on your IRC channel, but did you read? Mean time to recovery, good luck. Trackability. Once something gets into a supply chain, you want to make sure that you are able to track all of its assets. You want to make sure that every library is there for a purpose, that every component is defined and configured and has some kind of utility. It's not there just for its own sake. So the security engineer runs some kind of automated code scanner, gets this not entirely nice report, and then renders himself a dependency graph. And he goes like, oh. What is worse? Out of software that you might have shipped, some of the dependencies are not what you've intended and not what you've even added. You've just inherited that from folks like you. In terms of risk management and vulnerability management, you are going to scare off people way before your code is going to lose their money. My code as well. We've been there as a company. The worst thing within the supply chain and sub-dependency risks is not malpractice and vulnerable code. It is what I raised before. Some of that code may be maliciously injected or just for the fun. History knows examples. Contagiousness. Open source is extremely contagious by itself because you can pick up a nice library, fit into your product, and you're good to go. It kind of works. What happens next is some of the common frameworks distribute the same vulnerabilities across thousands of applications. This headline and this link, it is a report from one of the oldest automated source scanning tools, source code scanners, who identified that Apache struts, Apache Java components, and all the open source building blocks for enterprise apps have been distributing the same security bugs for at least a few years. Then once we realize that what we're distributing is contagious, we want at least to heal our software within our enterprise to fix it all. However, even if I raise, and I've been there as an open source developer, our customers raise it with us. They say, we think this part is suspicious. Luckily, we are security engineers ourselves, and we look at suspicious stuff first. This is the reason why we win contracts. Having asked them, have you tried it with other libraries or with other products? They say, yeah, but when we said that is suspicious, everybody said, well, no. There have been 600 people over the last year reading our source code. But public source code reviews and community reviews, they most likely hunt for low-hanging fruit, something that you could easily find, easily report, get yourself some credentials, and so on. Security bugs are hard to find. Sometimes the authors take years to find their own security bugs with extremely high skill and competence, unfortunately. So who finds the bugs faster? Our nice engineer who is integrating a few libraries together, he doesn't have an idea how they work. Or the guy who earns his living exploiting these libraries. With open source software, unfortunately, the answer is obvious. This used to be a typical enterprise bullshit theme. The source is open, and everybody will find bugs in it. Open source resisted nicely. The whole movement resisted nicely because people started trying to address security concerns. But the adversary market, the hackers, they're growing faster. There is more interest, financial gain in exploiting stuff than in fixing stuff. So it will be always easier for a concentrated individual to find security bugs in your product where you as a developer will not be able to do that. The other problem is the methodology. Basically, security industry has accumulated quite rigid, quite structured methodology on identifying vulnerabilities, informing everybody about them, making sure that everybody uses the latest fix, and so on, so on, so on. But once our developer puts some open source code on GitHub and somebody raises a security concern, he's like, yeah, I fixed that. How many people do know about that? How many people out of your user base know that you should update to the latest version, apply the patch, or whatever? This is a typical feedback from the external world towards an open source project. This looks wrong, line this, go read this manual. This is not entirely actionable. So there is an open vulnerability reported publicly for which an adversary is actually able to deduct some exploit to utilize it, but looking at which an open source developer actually finds it hard to make sense out of it. Like, yeah, really, I can read this blog post. How does it relate to my code? Adversaries will deduct it faster. I will stop here for a second. The vulnerability management is a very important aspect of developing new code. You will make errors. Everybody makes errors. The question is, how good are your mechanics at fixing them and informing them? And this is where we get to communication. Once an open source project updates some security concerns, what you do, you put that in your changelog. In this new version, we have eliminated 3 things we didn't like. What happens next? Maybe in a week or 2, if you're a part of popular ecosystem, some kind of blog post indexer or specialized repository mentioning bugs on your platform will accumulate that. How soon the security industry, which is able to deliver firewalls, code analyzers, and so on, will know about that? It's a question of luck. Incident, shitstorm in Twitter, or somebody leaks an exploit that this concern is actually a problem. This is where it gets to CVE, to the public database of vulnerabilities everybody should defend against. Basically, we rely on divine grace, and divine grace hasn't been very graceful to us so far. Because this is a survey by one of the leading industries source code and dependency scanning tools. 88% of the projects still report concerns only on change logs. Only 34% of open source projects deprecate vulnerable versions. So basically, you are running some code, you are going to a repository, and it's just fine. And you have no idea that the later version fixed some bugs. It's not deprecated yet. 25% are even worse. Yes, they do know that vulnerability happened. Yes, they fixed it, and they don't make any effort to communicate it. Like, yeah, the latest version, please run from master or from nightly builds. If you don't do, your fault. The epitome of this is modern JavaScript development. I am very sorry for you folks, because if there are any in this audience, you are getting boot ads too much. However, only 13% of vulnerabilities that are critical actually do get a CVE and public tracking of their risk, patching, and so on. So we have 87% of vulnerabilities reported like, yeah, it's somewhere on my web page, and the whole internet and all of my users can just stay vulnerable. Then there is a number of design concerns. Quite lately, we've been supplying our products and our tools as a solutions provider, where we grab a lot of assets, a lot of tools together, compose a final solution, and deliver it to the customer. It's always security related, obviously. When I got in these shoes, I felt it very differently. Because right now, it's my liability that every component I run, aside from just my software, is actually sufficiently secure. And it's going to be a few hundred of those components. I will not have enough time to do a proper source code audit, nor any of my engineers will have that time. I need some simple judgment scheme. And I will look at three things, being trained by other security directors in the business. First, you don't have something that looks like a secure software development lifecycle. Some of the open source projects, in fact, do. And you could see that by the way they manage their tickets and issues publicly. What is secure software development lifecycle? It is how early in your existing lifecycle you get to fix security bugs. The worst is after an incident. You lose a lot of money, you have to rewrite code, reroll all your systems, and so on. The easiest, when you plan your software. Secure software development lifecycle complements software development lifecycle so that security bugs are cheapest to fix, or they don't even happen, most of them. A lack of something that looks like SSDLC is a clear sign that the risk is unpredictable. The problem with SSDLC is you need SDLC first. How will you realize that you need SDLC if you don't realize that you have security failures? So it's kind of chicken and egg problem you're facing, and the answer is easy. Just be religious and adopt the safest way possible. Incentives. I think the most useful thing you can take away out of this talk is incentives. Security is not #1 interest of lone open source developer, if it's not a security tool, who is building something. He has limited time, he has other things to do in life. If it is a community, security quickly gets subject to politics. We want to spend this amount of time, we want to delay a release or whatever, we want to impact the whole community because of security. And community goes like, yeah, really, should we? Maybe some company should sell security support and we can go the way we do. Security is heavily dependent on how mature the development process is. And as we know, some projects are better without mature security, without mature processes, because some of them are still research projects. And to the end of it is qualification. As raised before, a ticking bomb is not having anybody qualified inside the open source project to actually build the type of security controls you're looking for. My favorite example is the Go language. The sole reason why standard cryptographic library for Go language is so good, and it's so good means like there is only 10% chance of fucking things up badly. So the only reason why it's so good because Google employs brilliant cryptographers, and Google forces these cryptographers to be involved with Go development. Once Go became sufficiently mature, Google has started hiring cryptographers into Go team. Presence of specific security qualification within the project is bare minimum. However, understanding of security concerns by core maintainer, but by somebody who defines what we do and what we don't, is crucial. And of course, bike shading. You don't make open source projects to become a famous rock star. Well, maybe you do, but I've got bad news for you. You do that because you have a very strong opinion on how things should work. Sometimes that involves bike shedding, and you get used to it. I can actually reinvent this crap in a much smarter way. In security, reinventing stuff is a bit problematic if you do it on your own. And what's worse, the results of what you've reinvented are much harder to audit, to review, and to comprehend. Is it even safe to run in production or not? So what happens? The other person reviewing what you've just invented, a new nice cryptographic scheme or a magical access control scheme, he's like, well, yeah, it looks good, let's merge. I'm done with bad news today, actually. And we have good 5 minutes to speak about something nicer. What to do when you are using open source software and you're in the high-risk zone where reliability and security matters. First of all, decide where you are. Understand and decide. You can actually afford yourself to spend personal time investing into security, or you can afford yourself the losses. There is no third choice. Third choice is wait until the losses. The easiest attitude towards code other people write is that it's malware, unless proven otherwise. Once you put something significant, which processes sensitive data, works with user input, faces the network, affects scalability, creates bottlenecks, whatever, something sensitive and risky, you want to define risk level and trust level. And you want to know that this stuff is kind of good, not because Google uses it, but because we've been monitoring it for a decade. That stuff is kind of bad because it's fresh, novel, we really like it, but we don't trust that. You want to scan the code during development, you want to scan the dependency code, you want to scan your runtimes, both of applications and infrastructures. You want to do pen tests in case of it's something that faces the network, you want to do audits. And all in all, to be safe when you are taking risky assets from the outside, you want to have some kind of SSDLC, which is Secure Software Development Lifecycle. One of our customers, when taking our open source library completely free of charge, he said, like, yeah, sure, we'll write you back in a month. I said, well, why? You guys are really busy? He's, no. We treat any external source code, even community vetted, even well-respected and recommended and so on, as if it is written by an intern from Milwaukee who just learned to code. And while I was terribly pissed off, you want things to proceed faster, all in all, you realize that to build something that stands against the test of time, this is a very viable approach. You want to since the open source pieces of your software are actually more risky, due to the reasons explained above, there are 4 things you want to monitor consistently. You want to keep an eye on vulnerabilities and not expect CVE and public vulnerability reports. You want to make sure that you watch their GitHub, you watch their mailing list, and so on, so on, so on. You want to be proactive on these risks. You want to look for security concerns. If there is something you run which you don't like, but you have to run that, it's fine, but you have to proactively build monitoring around it to prevent behavior which you suspect might hurt you in the long run. You want to make sure that for each component which you depend on, which is critical, there is a way for you to know that you're getting the actual updates, you're getting the right patches, at least when they emerge, you know about that. And this is the way we met some of our customers, and this is the way many open source projects meet their customers. Be proactive in finding who owns this, who runs this stuff. Become friends with them, or make your developers become friends with them on Twitter, whatsoever. Have some contact, because sooner or later, there will be an issue which you will want to escalate to real people. And since open source projects are rarely maintained by responsible companies, you want to have some personal touch. What if you're an author who is building something in the open source? You rely on the open source components yourself, obviously. First of all, whether you like it or not, if you want to ship your stuff to people that take security seriously, you'll have to have something that looks like secure software development lifecycle. It's actually easy. It's 5 phases. Analyze the risks, come up with the plan, implement securely, verify the implementation, and monitor it, and wait until it breaks, and then go fix it. And it goes in circle for ages. It doesn't have to be super formal. You don't need some forms, papers, and spreadsheets. Your team or your community just needs to be familiar with the idea. We code something only if we consider the risks. You need to have a security stakeholder, because everybody politically will be inclined to push things forward and ignore security. And foremost, you want to build communication processes. You want to be able to communicate all the things, all the problems I've explained before. Critical issues, patches, vulnerabilities. You want to deprecate, you want to publish your postmortems timely for the trust to your product to persist, to your project, and so on. What you don't want to do, you don't want to roll cryptography. Unless you've done that at least a dozen times, you don't want to roll out authentication, authorization, and access control. And you really don't want to do validation and sanitization. There are a lot of good tools for that. Open source, written by security engineers and vetted for a while. When you are thinking about the open source dependencies you are running from other people, just imagine yourself at the phase 2, being a customer, and treat them the same. And brace yourself, because it's going to be bad anyway. Questions?
Okay. How is it going with questions? I see hands. There's no doubt. Please, you are the first.
Thank you for so nice speech and very important information you mentioned. The question is about the open source software is the holy war that you just firing. I mean, closed source software, is it more secure than open source software? Because all of your speech is yes, that's exactly what I was trying to hear from you. Thank you.
Definitely no. The honest answer is all the software is equally vulnerable. The question is that software that is maintained by corporations, that is sold within a contract and liabilities, is easier to manage the risks in terms of you being a customer. In terms of the technical quality, developers make mistakes everywhere. There are security vendors who do provide security products without having competent personnel. As well as there are super bright open source projects which have blazing quality. It's not about the technical stuff, it's more about the risk management and the business on top of that.
More questions? Yeah, please.
Is there any global service? First of all, for example, if I found the security issue, can I push my
Report.
into global no? I mean, is there any global service where I can push my report to? For example, if I submit an issue on GitHub, you said the developer can just ignore it.
Yes. Most of the answer is actually in your question. The problem is there are two types of software where there is a disclosure policy, where there is an email and people say we will react and we will act appropriately. And there are projects where there isn't. And it doesn't matter whether they're enterprise and proprietary or open source. It just happens that open source is more frequently unmanaged in terms of disclosure. If you don't have a path to disclose a vulnerability, ethically, it's your choice. You could just pull it out like saying, this software is crap, you can exploit it this way. Highly likely that hackers will pick it up faster than project owners. The other way around is raising awareness in the community. Hey guys, these people, I have concern, I tried to inform them, they didn't take any notice of what I raised as a concern. If you rely on them, let's try to do something about it, but it's problematic and it works really bad in open source world. That's one of the reasons why I'm trying to raise awareness through talks like that. Because if you as an open source developer don't create the means to inform you about the vulnerabilities, full disclosure or only hackers will use it.
I see one more. Well.
Hi, good speech. Question, how you see the good patterns of good governance for the open source project? Because there are some wild open source and wild and dirty open source projects, and there are some good managed, like done by governance done by Linux Foundation or some guys like HashiCorp and etc. So what's your view about the pattern of good governance and?
Some of the open source foundations have amazing policies which they apply to all of their projects. It's not my job here on stage to advertise them, but some of them do, some of them don't. The easy way to distinguish is to look at their founding documents. If there is a policy of we do it this way, chances are high they really do. Linux Software Foundation does that, since that's the one you mentioned. Some of them don't do that. Some of the extremely popular software foundations keep on distributing vulnerable code for ages. In terms of governed open source, it either comes from foundation, very trusted developers with good reputation for doing the right thing, or it comes from the business. And even though it's open source and public, I would put more of my trust towards open source library from Google than towards brilliant open source library from single developer in Mongolia who registered his GitHub account 3 weeks ago, because he might not be from Mongolia and it might not be his first GitHub account. I'm a suspicious guy. In terms of governance, you need to see the face on the other side, and you need to see that this face is trying to put effort. Sometimes you can see the traces of this effort. Sometimes you see that saying we do care about security doesn't meet the reality. And you just make a judgment not about open source and not about particular product, but about the source which governs this open source. Anything else? I think it's overdue for the closing speech, and I see many faces hungry for a beer. Shall we wrap up, or another last question?
Yes, I have a last question. Thank you for your talk. And I would like to say that open source is not a way that we like it or we don't like it. We use it every day, and it's reality. So you are talking about dangerous things regarding to open source, but how can we as developers monitor the open source we're using in our projects automatically? Because CV and Maitri doesn't get a lot of real updates of the vulnerabilities, so we can just automatically parse information from those databases. What tools do you use to make sure that open source that is used in your projects is safe?
There are 3 layers to this question. First is easy. Most of the language-specific tools carry databases which are bigger than CVE. Most of the commercial source code scanners who have free tiers to use also have databases which are updated more frequently and which carry not just CVEs but a lot of community intelligence. For example, SNCC, one of the first big products to scan you for the dependencies, they typically publish some of the critical JavaScript crap and Ruby Python crap like a few weeks before it creates a Twitter storm. So it's an easy answer. The harder answer is you need internal process, and I raised it on one of the slides. You need internal process to vet what actually you use. To have a simple checklist of, I want to look at this, 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 and this, before I actually put that in production. And the third answer is, in the end, for the things which you can't really say whether they're good or not, you just assign a very low risk expectation. You assign that it's going to fail one day, and you just build defenses around it. I still run terribly vulnerable Python thing on my home server because that's the unique thing, and it does the thing I need it to do. But it sits behind a very strict firewall because I realized that it's poorly coded, and I want to compensate for that with something I trust.
Okay, thank you for the answer. And a small comment that if we're talking about JavaScript, you install any JavaScript application and you had 200 of dependencies, and it's not possible to review them even if you have 100 of ICE.
Indeed, that's the problem I raised in the middle. I don't have a good answer about 200 JavaScript developer dependencies other than avoid this crap.
Thank you.
Well, it was the last question. So thank you for the speaker.